Hopefully we go through the section without any mistakes. Let's see, is it recording? Yes, we have started the recording. So let's start. We are here where it says, so now we're looking at 2.6 transformation of functions, objectives. So we're looking at, by the end of this section, you have to know what a vertical shifting, horizontal shifting, reflecting graphs, vertical stretching and shrinking, horizontal shrinking, stretching and shrinking, even and odd functions. So they say in this section, we study how certain transformations of a function affects its graph. This will give us a better understanding of how to graph functions. The transformations that we study are shifting, reflecting, and stretching. Now, vertical shifting. Adding a constant to a function shifts its graph vertically upwards if the constant is positive and downwards if the constant is negative. So they say in general, suppose you know that the graph of y is equal to f of x. How do you obtain the graph? How do you obtain from it the graph of y is equal to f of x plus c and y is equal to f of x minus c? Given that your c is positive. So they say the y coordinate of each point of the graph of y is equal to f of x plus c is c units above the y coordinate of the corresponding graph, corresponding point on the graph of y equals to f of x. Does that one make sense, guys?
No.
No, ma'am.
Okay. All right. So they are saying, you know what vertical shifting is, isn't it? When you shift up and down, that's vertically. So when you throw something up and it comes down, that's vertically. So they are saying that if you have a function, which is y is equals to f of x. Okay, let's just go to the next one. They explain it. So they say we obtain the graph of y equals to f of x plus c simply by shifting the graph of y equals to f of x upward by c units. Similarly, we obtain the graph of y equals to f of x minus c by shifting the graph of y is equals to f of x down by c units. So when we come to vertical shifting, what we do is if you have a function y is equals to f of x, now the pen is no longer writing. This is not good. Why not? There. So if you have a graph, sure. Okay, sorry about that. Let's see if I say enable editing because my pen is giving me issues. There we go. So now they say that if you have a function, this function over here, y is equals to f of x, right? When we add a positive constant, c plus c, it means that, remember, when you substitute a value here, you'll get the y value. Are we all together there? Yes or no?
Yes, ma'am.
Yes.
So when you add
Yes.
c, it means that after getting the y value of c, you add c. So if I got 3 and my c is 2, then your new y value will be what? Will be your new y value will be 5. So meaning that the initial point of y is equals to f of x. If x was 3 and y was 7, for example, and you add your c, so meaning that your new x value will still, your new point will still have an x value of 3, but the y value will change, which, let's say if you add by 2, that will be 7, 8. Meaning that every point on this blue graph here will have the same x value, but the y value will move upwards by c. In this case, if you choose c to be 3, so every x value of these points, if I choose the x value here and I add by positive c, it means I'm moving up here. The y value is only changing, but the x value remains the same. Do you see that? So if you added by c here, it means you're just shifting this blue graph upwards by c units. So the distance from here to here is just c.
7
Are
plus
we all
2.
together there?
7 plus 2 is 8.
Yes.
Yes.
So meaning, yes. So basically all the y values, you're just taking the blue graph and moving it upwards, which becomes this red graph here.
Okay.
Yes, but this x value remain the same. Because remember, when you substitute x here, you get the value of here, and then which is the value of y plus c. So only the y values will be changing, not the x values, when you're shifting vertical up and down. Are you all together there?
Yes.
Yes, ma'am.
So now when you're shifting downwards by c, meaning that you take the blue graph, all the points will be minused by c. If this point was 3 and 4, for example, 3 and 4, and your c was 2, meaning when you minus this point, the new point will be what? 3 and 2. If this point here was, let's say, 1 and 5, the new point here will be, if you minus, basically, okay, not this point, but the new point will be minus that. So meaning you are taking this whole graph and moving it downwards by 2 units. So only the y values will be changing. So that is called vertical shifting, up and down. Are all together there? Any questions? Guys, I need 3 yeses to move forward.
Yes.
Yes, ma'am.
Yes, ma'am.
Now they say, look at this graph of y is equals to x squared to sketch the graph of each function. Right? So now, this graph, do we know how f of x looks like? F of x is equals to x squared. Do you know how it looks like?
Yes.
Yes.
Now, be careful. Listen to this. If you don't pay attention to this section, you'll have a problem with trigonometric graphs. This is a very important section you need to understand, because trigonometric graphs, I'm not going to tell you vertical shifting, because it's something that we're currently doing now. So I'm just going to say shift by pi whatever, or shift by 3 units vertically up or down, or to the left, to the right by 30 degrees. And we're not using 30 degrees. You'll see when we get there. So we all know the graph of f of x is equals to x squared, isn't it? Do we
Yes,
know
ma'am.
it?
Yes, ma'am.
Yes.
So meaning that if we were to draw this graph over here, right? We know that it looks like this. This is how it looks. Okay, let me choose a different color. We know it looks like this, our graph. Am I lying, or I'm okay?
No, you're not
Correct.
lying. You're not
Okay,
lying,
ma'am.
ma'am.
So now, do you see that this is our f of x? Do you see that this is our f of x? Because I added by 3, where am I going? Up or down?
Upwards. Upwards.
And which
Upward,
value is affected?
upward.
The value of x or the value of y? Are
The
we
value
adding
of
the
y.
3 to the value of x or the value of y?
The value
The
of
value
y.
of y.
Value of y,
Well
ma'am.
done. Well done. So meaning every point here, the y value here, if this was a number, -1 and something, you add by 3, this point here, it has to move 3 units up. So let's say this is like the 3 units up. Let me choose a different color. 3 units up, 1, 2, 3, it will be here. This point will also move 3 units up. Sorry about that. This point will move 3 units up also. It will be somewhere here. We're just showing an approximation. You can use points if you want to show. This one will be 3 units up. Okay, what's going on with the pen? So this point will be here, 3 units up. This point will be here. This point will be here, 3 units up. This point will be here, which is 3 there. So all these points, they move 3 units up like that. So the new graph will be like this, which is the graph of g of x. Are we all together there, guys?
Yes.
Yes, ma'am.
Thank you.
Yes, ma'am.
So
Yes,
meaning
ma'am.
that here, we are moving 2 units down. So what we do is we go and draw our f of x. We know our f of x is this one,
And now y is -2.
right? So since our f of x is that one, we're now moving 2 units down. So meaning that this point will move 2 units down. This point will move 2 units down. Okay, I don't know why the pen is doing this. Sorry, my apologies. This point will move 2 units down and will be 2 units down, 2 units down. So it'll be something like this. Here where it will be -2 because here it was 0. I will all sorted. 3 yeses, then I move forward.
Yes.
Yes, ma'am.
Yes, ma'am.
Yes.
Yes.
Anastasia.
Yes.
So if they said like g of x into negative x squared plus 3, that means like the graph should be pointing downwards. Correct.
So if they say g of x is equals to negative x squared, yes.
Plus 3, yes. So it should be pointing downwards.
Yes.
Okay, thank you.
So do you see that they said our graph moved 3 units up, which is the blue one, because the initial one was the one, which is the red one. Please mute. That's why I think I'm being distracted. Someone is not muted. Okay. So now the blue graph is the original f of x. So it moved 3 units up, which becomes the red one, and then it moved 3 units down, it becomes the purple one. So the function f of x is equals to x squared is sketched in figure 1. Now observe that f of x is the function, and we just moved the function f of x by 3 units. So the y coordinates of each point on the graph of G is 3 units above the corresponding points on the graph of f. So only the y coordinates are changing. Sorry. This means that the graph of G, we shifted the graph of G by 3 units upwards. Similarly to the graph of H, we shifted the graph of F downwards by 2 units. So we get figure 1. Are we all okay with horizontal shifting and vertical shifting? I mean vertical shifting, not horizontal.
Yes, ma'am.
Thank you.
Right,
Now
ma'am.
let's look at horizontal shifting. When you are shifting in the horizontal, which plane is the horizontal, guys? In the Cartesian plane.
Yes,
So meaning which ones are changing? Remember how vertically, you're moving
Vertically
here,
up and down.
which is the y, isn't it? So the y's are changing. Now horizontally you are moving here. So now which ones are changing? Is the x. So meaning that inside the function, isn't that there's an x? So inside the function we'll be moving, we'll be adding, or we'll be subtracting, because we are changing the x now. Are we all together? Yes.
Yes, ma'am.
So there we go. Suppose that we know that the graph of y equals to f of x. How do we use it to obtain the graphs of f of x plus c and f of x minus c for c greater than 0? You need to be very careful now. Remember for vertical shifting, when I add, where do I go? Up, isn't it?
Yes, ma'am.
Right?
Yes.
When I subtract, I go down.
Yes.
Now, when you are
To go
moving
down.
vertical, yes, when you are moving horizontally, when you add, you go to the
Right.
Left.
Right.
right.
Left.
Right.
Left, sorry.
Left.
When it's negative, you go to the right.
Right.
When it's positive, you go to the left. So they say, okay, so the value of f
Can
of
you
x
please
minus
repeat that?
c, okay, listen. The value of f of x minus c at x is the same of the value of f of x at x minus c. Since x minus c is c units to the left of x, it follows that the graph of f of x minus c is just the graph of what? Shifted to the right. Meaning that initially we knew when we add c, we move up. When we subtract c, we move down. That's for the vertical shifting. But for the horizontal shifting, it's the other way around. When we subtract, we move to the right. But when we add, we move to the left. Do you see that? Guys? Do you see that?
Yes.
Ma'am,
Yeah, got it.
ma'am, can I ask?
Yes,
Can
ma'am.
I ask something?
Ask.
No, let's do it principal, man.
You can ask. I'm listening. Okay, then I'm moving on then. So they're saying that, please mute. They're saying that the following box summarizes these effects. So horizontal shift of graphs. Suppose that C is positive. Now, when you subtract, you are shifting the graph of f of x to the right by C units. Now, when you add, you are shifting the graph to the left by C units. That's the transformation you're doing. Do you see initially you had this blue graph and then you subtracted C. Now you are on the right. Now initially you had this blue graph. Now you added C. Now you move to the left. Are we together?
Yes, ma'am.
Yes.
Yes, ma'am.
Reason being, if you go and solve for x, you take this and equate to 0. If you say x minus c equals to 0, then x is equals to positive c, meaning that this will end up in this part of the function. That's what we noticed when we look at the a parabolic function, that the turning point there, when you have y is equals to x minus p squared plus c q. Remember that this we equated to 0. And we noticed that the x value of this is what? Is p.
It's
Yes,
But
ma'am.
it's something that we'll also go through later on.
Yes,
Are we
ma'am.
all together with the horizontal and vertical shifting?
Yes, ma'am.
Ma'am, I
yes,
have a question,
ma'am.
ma'am.
Okay. So now let's look at this one.
Yes.
It says use the graph of f of x to sketch each graph of the function. So now we know that f of x is like this. This is what we know. What transformation was made here?
The graph added 4. So it's gonna shift to the left by 4 units.
Thank you. So we're going to shift the graph, this red graph, by 4 units, meaning this one point comes here. I don't know why the pen is doing this. Okay. Let me do this. Discharge. Okay, where's the word? Here it is. So it means here we shifted. You see that you're adding in the x, meaning that you're doing a horizontal shifting. So then the graph in A, the initial graph is like this. Okay, I need space. This is the initial graph. So meaning that now they are telling you that we are shifting the graph here because you are adding. So when you are adding, you're moving to the left or to the right. You said what?
To the left.
Right.
Left.
To the left.
Thank you.
To the left.
Thank you.
So you're moving 4 units to the left. Look at this is a parabola, guys. Look at this. You're moving 4 units to the left. You see this point becomes a point here. Right? And this point becomes 4 units to the left. So we're only changing the values of x. This x value here comes here 4 units to the left. So it becomes something like this. Now, if you don't remember whether you are moving to the left or the right, do you see that this is a parabola? Guys, mute.
Please mute.
Who's that? I'm opening emails now. Okay. Now, if you don't remember whether you're shifting to the left, to the right, when adding to the x, do this. Do you see that this is a graph, a parabola of the form ax minus p squared plus q? Do you see that?
Yes, ma'am.
But in this,
Yes.
Yes,
in
we can
this,
avoid it.
in this case, our q is equals to 0. Do you see that? So this is equals to 0 here. And how did you find the x value of the turning point? You equated this inside to 0, isn't it? You said x minus p is equals to 0. Therefore, x is equals to p. That's what you did, isn't it?
Yes, ma'am.
Yes.
Now, let's equate this and see. So if you equate this to 0, x plus 4 equals to 0. So x is equals to minus 4. Do you see we are correct that we move to the left? Because minus 4 will be here. This was 0, minus 4 will be here. So meaning that we were right by saying we are moving to the left. Are we all together?
Yes.
Thank you. So this
Yes,
is
ma'am.
g of x. Now, this one, it means you're moving 2 units to the right. So it will be here. All the x values change to the right. So it will be something like this. I'm not drawing things to scale, guys, but I'm just showing you. So to the right will be this one. All together with the horizontal shifting to the right, to the left.
Yes, ma'am.
Yes, ma'am.
Thank you. Now, in the exam, I might give you a graph and I ask you to describe the transformation. So you say from the initial graph. So we call these mother graphs, right? Remember, with mother graphs, it's y is equals to x, y is equals to x to the power of 3, or parent function. Some people call it a parent function, y is equals to x squared, right? Those are parent functions. Then from a parent function, you can be able to do transformations like these. Are we all together, guys?
Yes, ma'am.
So in the exam, I combine horizontal shifting, vertical shifting, stretching, shrinking, and whatsoever. I say, if you shift the graph 3 units by 3 units and you what, at the end of the day, which of the following represents the graph of the whole statement? And you also see that in the assignment. And because your exam is multiple choice, unless it's changing, I'll let you know, but it hasn't changed at the moment. So it's multiple choice, meaning that you need to understand your work, and I'm going to say which of the following represent the above. Okay, so to graph G, we shift the graph of F to the left by 4 units. Now to graph H, we shift the graph of F to the right by 4 units. And there we go. These are the graphs we drew. Now reflecting a graph. Reflecting a graph. Next. Do you have an idea of what reflecting a graph is, guys?
Yes. Yes, ma'am.
Yes.
Yes.
What is it? Remind me.
Is it turning the graph into the inverse?
But when you're turning the graph into an inverse, where are you reflecting the graph?
From
To the negative.
point of origin?
On the x axis.
Negative y.
Axis or not the y. Ma'am, aren't you
Yes.
basically
of x.
plotting your x-axis and your y-axis?
No?
From the
Oh.
x is equals to y line?
Yes, on the line. So when you're finding an inverse, which I don't want to talk about now because it's coming later, you're reflecting on, look, I'm still talking about it. You're reflecting on the line y equals to x, right? But now when you're reflecting about the x, okay, let's look at this scenario before we even enter reflecting. I have this function. Y is equals to f of x, right? I have that function. Are we all together there?
Yes,
Yes.
ma'am.
Now, when
Yeah.
I'm putting Let me draw my Cartesian plane. This is my Cartesian plane, or our Cartesian plane. Now, y is equals to, I put a negative here. If I put a negative to f of x, what is changing? Let's say here my x was what, and I got 2 here. My y value is 2, isn't it? Now, if I put negative to f of x, my answer will be what? Negative 2. I was here and I jumped to here. Are we all together?
Yes.
So someone who's standing here and someone who's standing here is the same person, but they are reflected. Which line did they cross?
Y is equals to X.
Which line did they cross?
X. The X intercept.
Thank you.
line
So, thank you. Please mute now. Let me summarize. Thank you. Meaning that if I have y is equals to x, f of x, and then I went and multiplied by negative the f of x, I have reflected about the x-axis. Someone is not muted.
Mama,
Who is it? Who am I supposed to remove? Okay, I didn't see them. Are we all together there, guys?
Ma'am, can you repeat?
Yes.
I couldn't hear you.
Okay, I am saying that we had initially y is equals to f of x. Let's say f of x is 2, isn't it? Now, if I put negative next to f of x, I get what? Negative 2. Do you agree?
Yes.
Which
Yes.
line did
Yes,
I
ma'am.
jump? From here to here? Which axis did I jump?
X.
The horizontal
The-
ma'am.
Thank you. The x-axis. Now, since you jump the x-axis, meaning that if you have y is equals to f of x, and you come and take y equals to negative f of x, you have reflected about the line that you have jumped, meaning that you have reflected about the x-axis.
Excellent.
Makes sense, guys?
Yes.
Because these are
Yes, ma'am.
y's, they were positive and they became negative. Now, y is equal, can you guess, if I have f of x, where can I, so now I want to reflect about the x-axis. Where do I put the negative? Let's just put a guess. Where do I put the negative?
At the y.
And please repeat the question.
Thank you. It will be in the negative x's because I want to jump there. I want to jump the y's. I moved from the positive x's, I'm going to the negative x's. Or I moved from the negative x's, I'm going to the positive x's. So now since the x was positive and it moved to negative, I jumped the y-axis. Meaning that if I had a function like this and I became like this, I am reflecting about which line. Which line did I jump? The y. So I'm reflecting about the y-axis. Does it make sense now?
Yes.
Okay, let's go. Suppose we know the graph of y is equals to f of x. How do we use it to obtain the graph of y is equals to minus f of x and y is equals to f of x? So this is the reflection about which line, guys?
The y-axis.
The Y.
The y-axis, because the y values are the one changing. Because look at this. If you had y is equals to f of x, and the y values, you put a negative next to y and say f of x. This is the same as y is equals to minus f of x. Do we agree that?
Yes, ma'am.
So the y values are the one changing. And since the y values, the only way you can change the y values is jump the x-axis in the Cartesian plane from here to here. So meaning you are reflecting about the x-axis. Now, if you introduce a negative x in front of x, you are reflecting about the y-axis. Makes sense?
Yes, ma'am. Yes.
Thank you. So they say the y-coordinate of each point of this graph is simple the negative of the y-coordinate of the f of x's. So the desired graph is reflected about the x-axis. because the y is the one that is changing. Now, because here, you know that here I have positive x's and I have negative x's, meaning that if your x was positive and you take it to negative, you are jumping the y-axis, meaning that the y-axis is your mirror that you are reflecting. So this means that you are reflecting about the y-axis. Are we all together, guys?
Yes.
Yes, ma'am.
Okay, good. So there we go. So the following box summarizes these observations. Now reflecting graphs. To graph y is equals to minus f of x, meaning that you're reflecting the graph of y, f of x in the x-axis, and the graph to graph y is equals to negative x, you are reflecting the graph of y of f of x is equal in the y-axis. I don't know what I'm saying now, but I think it makes sense. So meaning that initially you had this graph. Now multiplying by a negative on the y, you obtain this graph. Then you have reflect because you have jumped the x-axis. The x-axis become your mirror. The x-axis become your reflecting point, meaning that you have reflected about the x-axis or in the x-axis. So here you have reflected in the about the y-axis or in the y-axis because your y becomes your mirror. Now sketch the graph of each. Bugayo. Bugayo. Sketch the following graph. Ooh, what am I doing? Sketch the following graph, guys. Where's the... Do you remember the graphs? I think you already know the graphs because I showed you the answer. Should I explain how the answer was obtained?
Yes.
Okay.
No.
So now we have A. We know that f of x is equals to minus x squared, right? And then we have B. I think it was g of x is equals to minus square root I. No, it wasn't minus. It was square root of minus x. Are you all together? Do you remember the parent functions? Yes. Thank you. So what is the parent function of f of x?
X squared.
X squared. Thank you. So the parent function of f of x is what? Let's call it h of x, which is x squared. Now you go and draw the parent function first. You go and draw the parent function. Oh, this chicken. There we go. So this is the parent function. Do you see that?
Yes.
You know it. But what did I do to the parent function, guys?
It's a negative.
There's a negative. So where did they reflect it?
Y-axis.
Guys, look at this. We have y is equals to x squared. I introduce a negative in front of y. It becomes x squared. Then this I divide by negative. This becomes y equals to negative x squared. So what did I...
faces down.
Thank you. Because I introduced a negative here, I simplified this as this. So it faces down, meaning that the y's are changing. Because here the y's are positive, here the y's are negative. The y's are the ones changing, meaning you are reflecting about the x-axis. So the graph is facing down. All together there.
Mm-hmm.
Good. Let's go to g of x. So g of x is equals to the square root of negative x. What is the parent function for this one?
Y is equal to X.
Y is equal to
Negative
x.
X, ma'am.
Negative x.
Yes, ma'am.
No.
Will reflect the y-axis.
The what?
Y is equal to ax plus c.
No, that's not the parent function.
Y is equal to square root of x.
Thank you. So the parent function is y equals to square root of x.
X.
You remember the y equals to square root of x graph, isn't it?
Mm.
How is it?
It starts from it bends in and so.
Thank you. So it's like this. Do you see that?
Yes, ma'am.
So where is the negative here? At X or at Y?
At X.
At
At X, ma'am.
X. So where
Yes.
am I reflecting?
Upon your Y. X. On your Y
About-
axis, ma'am.
Thank you. So on the about the Y-axis, so your graph will look like this. It should be the same, guys. Me, I don't know how to draw.
That's cool. We understand.
I want stress, ma'am.
Thank you. Are we all sorted now?
Yes.
Yes.
So if I add and I say by 2 units, where do you think your graph will go? If I add 2 there,
To the left.
Go up vertical.
thank you. Go up vertical, meaning this point will be somewhere here.
Mm-hmm.
All these points, then it will be something like your new graph will be like this.
Okay.
Yes. If I subtract the mother function by 5 units, meaning that this graph will be negative here somewhere, then it might be like this. There we go. I hope it's making sense. I know I took over your time, but I apologize. So this is what we got. They say we start with the parent function, which is y, or the mother function, which is y equals to x squared. The graph of f of x is equals to negative x squared. Is the graph of y equals to x squared reflecting about the x-axis? We are right, and this one we were right as well, reflecting about the y-axis. Hey!
Oh, ma'am. Ma'am.
I saw something. What is the domain of this? I hope you're not very quick to see it. What is the domain of that?
It's equals to 0 or greater than 0. Oh, of the
X is less or equal to 0.
Less or equal to 0.
Y less or equals to 0.
Otherwise, it's undefined.
Undefined, ma'am.
Yes, but okay. Can someone explain it in a, you call it layman's term or in a streetwise term? If I see an old lady and I say, my x values have to be negative, why?
Because we can't have a negative under the square root, so we need to multiply. We need to have a negative x.
Okay, but there's a negative x in here.
The x's cancel each other out. That's why we need to for it to be negative.
Thank you.
Negative, yeah.
Right. I knew what you meant. So the negatives have to cancel each other out. Remember, we did say that anything under the square root should be positive. So meaning what is under the square root is x greater, but it should be positive, greater or equals to 0, isn't it? So you divide by -1, you divide by -1, the x changes sign. So therefore it means the domain of this should be x less or equals to 0. By the way, you need domains and range. Everyone, go and learn domain and especially domains next week, because I might ask a favor next week on the date of the class. You see, I'm telling you now. Yes, we might change it. So go and by Friday this week, understand your domain and range, but domain specifically, because that's the part of we need to cover. Now let's look at vertical stretching and vertically shrinking. I want to, can we discuss that? What do you think happens here?
Yes,
I want you to
I
imagine.
think it's it.
Let's start with vertical stretching. What do you do?
I think, ma'am, we are stretching the y values, ma'am.
Okay, let's see.
We are stretching the x values.
No, the
Let's
carrier.
see. Suppose we know the graph of y is equal to f of x. How do we use it to obtain now the graph of y is equal to f times f of x? So you're saying that we're stretching. Okay, let me not ask the question first. I might confuse you. So suppose we know the graph of y is equals to f of x. How do we use it to obtain the graph of y is equals to c times f of x? The y coordinates of y is equals to c times f of x at x is the same as the corresponding y coordinates of f of x multiplied by c. Okay, now listen. Multiplying the y coordinates by c has the effect of vertically stretching or shrinking the graph by a factor of c. Are we hearing each other?
Yes.
So they say when you have vertically stretching and shrinking, to graph y is equals to c times f of x, where c is greater than 0 in this case. If c is greater than 1, meaning c is 2, c is 3, c is 4, then you are stretching the graph of y is equals to f of x vertically by a factor of 2. Of c. Does it make sense, guys? Hello?
May you please repeat that?
Yes.
So they're
It's
saying
not
that
for now.
if the value of c is greater than 1, meaning that c is 2, 3, 1,5, then you are stretching the graph by a factor of c.
Okay.
Is it making sense, guys?
Will there ever be a question where they'd ask you to
No.
What?
like the value of c would be like half, hence shrinking the graph?
Yes. Yes. So meaning that if it's between 0 and 1, then you are shrinking the graph.
Okay, thank you.
Okay, let's look at it in terms of a balloon, guys. As I said, I'm not good at drawing. This is a balloon, a proper round balloon. Ne? If you put your hand, one hand here, one hand here, ne? And stretch it, pull it this side and that side, what will increase?
The length, ma'am.
Well done, the length. Does it make sense, guys? Imagine pulling the balloon up and down. Like you have a balloon and then you're pulling it like this. So basically what is increasing? The height. Do you see that? Guys, am I seeing it alone?
No.
No, ma'am.
No, ma'am.
We see that, ma'am.
So it means that if you are increasing it, so if you are pulling it up and down, you hold, the thing is, now I'm doing my hands. This is the balloon, you hold it and you pull it this side and you pull it that side. So the height, the length, it will look like this. Do we agree that it will look like this? Something like this. Meaning
Yes.
that in the Y, it has lengthened up. The height there, it has lengthened up. The X values remain the same, but the height they lengthened up. Look at here. You see, you were here. You pull it down, it becomes red. You were here, you pull it up, it becomes red. Do you see that? Does it make sense, guys?
Yes, ma'am,
Yes.
it does make sense.
Good. Now take the same balloon with the same hands. Now squeeze it. Squeeze this balloon. What happens? Shrink
We are
it by.
increasing the length.
Do you see? Yes. So you are decreasing the length. The length was here. Now you are here. The length was here. Now you are here. Does it make sense? The stretching and the what's this? The stretching, the vertical stretching and the vertical shrinking.
Yes.
So now say use the graph of f of x is equals to x squared to sketch the graph of each function. Now, by looking at the graph, what are you doing in A and what are you doing in B?
I think, ma'am, in A we are stretching and on B we are shrinking.
Okay, so if we are stretching, here's our parabola. Our mother parabola. Here's our mother parabola. Where do you think the graph of 3x squared will be equals to, will be? If we stretch it, what happens to it?
It's gonna move towards left axis and right axis, if I'm not mistaken, ma'am.
Not in the x. Remember, it's not moving in the x-axis. When you're stretching a balloon, does it become thinner or thicker, guys?
Thicker.
It becomes thinner.
Ma'am,
It
You
becomes
become
thinner.
thinner.
it's wider.
Yes.
So it becomes thinner. When you're stretching a balloon, it becomes thinner. Ne?
Thinner. Yes.
Yeah.
So you're assuming it will be outside or inside the graph?
Inside.
Inside.
Inside the graph.
Yes.
Inside the
So meaning that when something becomes thinner than this, it will be something like this, isn't it?
Yes.
Like very close to the y-axis.
Yes. It will be thinner because you're stretching it. I don't want you to draw it with points or draw it with y-axis. I just want you to understand that when you're stretching something vertically, the balloon becomes thinner. So meaning it will be thinner than the mother function or the parent function.
And the parent function is equal to x squared.
Do you see that? So now for h, you say h, we are doing what?
We're shrinking, ma'am.
We are shrinking the graph. So if
Yes.
you have this blue graph here and you press it, like the balloon, when you press it, does it become thinner or fatter?
Better.
Do you see that? So meaning that it will be wider than the original
wide.
one
Yes.
because you have shrink it and then it becomes wider. Does it make sense when it comes to shrinking and stretching?
Yes.
Yes, ma'am.
Good.
Yes, it
Yes, ma'am.
does.
So now you can go and now you can go and sketch the graph like that by using points and see, oh, the parent function was like this. You draw the parent function, and then draw the other one. Do you see that? Now, when you use points, it will be easier. But when you use the x-intercept and the y-intercept, it might not be as easy to see that unless you keep in mind that when I'm stretching something vertically, it becomes thinner. So it will be thinner than the original graph. When I'm sitting on a balloon or I'm pushing the balloon, I'm shrinking it, basically.
Oh, ma'am, I have a question, ma'am.
Yes.
Do the rules change if the A is negative, ma'am? The x value, in fact.
If you mean -3.
Yes, ma'am.
Yes.
If I put -3, what have I done now? There's another transformation that I did. What did I do?
Man, the graph is going to point to the
Yes,
downside.
downside, ma'am.
Reflection.
Thank you. You have
The
performed
reflection.
a reflection, meaning that there are two transformations here. You have stretched the graph by 3 units and reflected the graph by what's this? You have then reflected the graph, but you have okay. So if you put a negative here, you have stretched the graph by 3 units and then reflected about the x-axis. So your new graph will look like this. So you have performed 2 transformations instead of 1. So you have combined the above transformation and this new transformation. That's what you're doing. Makes sense as now.
Yes, ma'am.
Thank you. And in the exam and in the assignment, I combine the transformations. So the graph of G is obtained by multiplying the y coordinates of each point of the graph of f by c by 3. That is, to obtain the graph of G, we stretch the graph of f vertically by 3 units. There we go. As we said, when you're stretching, something becomes thinner. So the purple graph is the mother function or the parent function. And then because we stretched it, the red one becomes becomes now the 3x squared function. Now when you sit on a balloon or when you press the balloon, it becomes wider. Therefore, h of x is equals to 1/3x squared. Are we sorted?
Yes.
Yes, ma'am.
Now let's say the graph of h is obtained by multiplying the y-coordinates of each point on the graph of f by 1/3. That is to obtain the graph of h. We shrink the graph of f vertically by a factor of 1/3. The result is the widest parabola in figure 6. What did I do now? Or something. Okay. Horizontal stretching. Oh, sorry. Now, have you noticed something, guys? It's like life is easy when it comes to vertical, ne?
Yes, ma'am.
Horizontal, very complicated. Very complicated. Horizontal shifting and shrinking is in a relationship. Please mute. Now let's look at horizontal stretching and shrinking. Now, we consider horizontally stretching and shrinking, meaning that now we have a balloon, you are holding this side, another hand is holding, and you are pulling like that, or you are pushing like that. Do you see that? Now, by just looking at it, guys, when you pull it apart, it becomes what?
It becomes longer, ma'am.
It becomes longer. When you push it inside, it becomes what?
Wider.
Wide. There we go. So it becomes, yeah, close, close, close. When you pull it, it becomes, it's like a string. When you pull it, horizontal, when you pull it, basically, and shrinking, stretch. When you stretch it, let's use the word stretching. When you stretch it, the string, you can see that even the things are, yeah. Let's just continue. Let me stop talking. Now we consider horizontal shrinking and stretching of a graph. If we know the graph of y is equal to f of x, then how is the graph of y equals to f of cx related to it? Now, the y-coordinate of y is equals to f of cx at x is the same as the y-coordinate of the function at cx. Thus, the x-coordinate in the graph of y equals to correspond to the x-coordinate in the graph of y equals to multiplied by c. Now, which one remains the same in this case? The y-coordinate or the c-coordinate? I mean, the x-coordinate when you're doing a horizontal shifting?
Y.
The y
The
coordinates.
y-coordinate. There we go. Now,
Right.
look. So, meaning they say, look at this in the other way around. We see that the x-coordinates in the graph of y is equals to c and f of c times x are the x-coordinates of the graph of y multiplied by 1/c. In other words, to change the graph of y equals to f of x, which is the parent function, to the graph of y is equals to c times x, we must shrink or stretch the graph horizontally by a factor of 1/2. So in this case, we won't be talking by, 1/c. In this case, we won't be talking about c, but we'll be talking about a factor of 1/c. As summarized in the following box. So we still assume c is greater than 0. So we say if c is greater than 1, ne? It means that we have shrank the graph. Okay, that is to shrink the graph of the parent function horizontal by a factor of 1/c. Is it entering, guys?
Yes.
ma'am.
Yes, ma'am.
Now, look at the difference. That's what I'm saying. Look at the difference. They on vertical and on what's this? On vertical, we say if c is greater than 1, what are we doing? We are stretching. Do you see that? That's what we said. Let's go back.
Yes.
We are stretching. And we say if c is between 0 and 1, we are shrinking. Now, when it comes to horizontal, we are saying something else, right? We are saying that if c is greater than 1, we are shrinking. But which factor? By a factor of 1/2. There we say that if c is greater than 1, we are stretching by a factor of C. And if C is between 0 and 1, we are shrinking the graph by a factor of C. So don't get confused. Now, so we go back, horizontal shrinking and stretching. So we have this graph where we say y is equal to C times f of x. So now C is greater than 1, meaning that we took the parent function and we shrank it horizontally by a factor of 1 over C. And if C is between 0 and 1, it means we have stretched the graph of y f of x horizontal by a factor of 1 over C. Now, look at this. So the graph of y is equal to f of x is shown in figure 8. Stretch the graph of each function. Sketch the graph of each function. I'm tired, guys. So if they say sketch the graph of each function, look at y is equal to 2x, f of 2x, and y is equal to f of half. And which one are we shrinking and which one are we sketching? And by what what is the factor? Describe the transformation of A. Guys, describe the transformation of A. What did we do?
We're stretching the graph.
Is she
Ma'am,
right?
Yes, ma'am, she is right. We are stretching the graph, ma'am.
We are stretching. No, we are shrinking.
By what
we are
factor?
shrinking. We are shrinking and B is stretching.
By what factor?
By 2.
Let's go back. A, please mute. A, you are saying A, we are shrinking or stretching. Let's start there.
We are
We are
shrinking.
stretching, ma'am.
By what
Stretching.
factor?
Shrinking by 2.
So we are all agree we
By
are
2.
shrinking, right? By what factor?
Yes, we are
One of-
shrinking. By 2.
By 2 factors, ma'am.
1 over 2.
By 1 over 2.
Shrinking by 2.
Let's read. Tell me when you're done reading.
We are done.
We are
Done.
done.
A, we are what?
We are shrinking. We are shrinking by 1
By
over
what
2.
factor?
By 1 over 2.
By 2.
B, we are doing what?
We are stretching.
stretching.
We are
By what
stretching.
factor?
By 2. By 2. 2.
Thank you. Now let's look at figure 8, right? How do you think A will look like?
It will look more close together, like more
Okay.
compressed.
Yes,
Then
or
let's see.
compressed, ma'am.
So you are saying it will be something like this.
Yes.
Yes.
Okay.
Yes.
And then B will be what?
It will be more wider.
Something like
Wider.
this.
Yes.
Yes.
Yeah, far apart from each
Yes.
other, ma'am.
All righty. Using the principle described in the preceding box, we shrink the graph horizontally by a factor of 1 over 2 to obtain the graph in figure 9. And we stretch the graph horizontally by a factor of 2 to obtaining the graph in figure 10. It's a question I like putting in the exam and say, describe the transformation. Just letting you know. And then when you don't get a distinction, you say it's me. Me, I'm giving you the answers. Are we all okay with stretching, shrinking, horizontal, and everything? Shifting and whatever?
Yes, ma'am.
Danko.
Yes, ma'am.
So let's go to even and odd functions. If a function f satisfies f of minus x is equals to x for every number x in its domain, then it's called an even function. For instance, the function which you know, which is a mother function or parent function of a parabola, if you put a negative and simplify, that will still be f of x. So meaning that the graph of an even function is symmetric about its origin. I'm sorry, about the y-axis. Did that make sense?
Please repeat that.
They are saying that if f of x satisfies this, then you say this is an even function. Meaning that if I take f of x and put negative x and I get f of x, then that's an even function. And they say even function are symmetric, meaning that they're like my hands, the palm of my hands. If I put, this is the gap between the hands I close, this one. So this is exactly like that. That's the reflection about the x-axis. I mean the y-axis. What am I saying? Symmetric. I'm tired, guys. The graph, that's symmetry. When symmetric, meaning that on the y-axis, the left part is the same, exactly the same as the right side. Did I make sense, guys? Or maybe I just mumbled it?
You were mumbling, ma'am.
You were mumbling.
Ish, ma'am.
Okay. Let me put it in a very simple term. Let's say you are given a function. This is your function. Do you see that f of x is equals to x squared? Ne? And they tell you, is this function even or odd? For you to say this function is even, this must happen. You take that function, f of x is equals to x squared. You put a negative x in the function and simplify it. We know that this will become positive x squared, isn't it? Now, since
Yes.
this is back to that, which is equals to f of x, meaning that if I take f of x, I put a negative inside and I still get f of x, then we say that this function is an even function. Make sense?
Yes,
ma'am.
it does.
Yes.
Now, since it's an
Sure.
even function, it means that the other half will look like the other half on the y-axis. When you jump the y-axis, that's where symmetry comes in. It's symmetric with respect to x-axis. Like your hands are the same. Not all of us have noticed. My apologies there. Meaning that this part here is the same as this part here because they are symmetric about the y-axis. So even functions are symmetric about the y-axis. All together. Yes or no?
Yes.
Yes.
Yes, ma'am.
Yes.
This means that if we have plotted the graph of f greater than 0, meaning that if we have plotted the graph of this graph like this, x greater than 0, it's this graph here, right? Let me write it here. Only x greater than 0 for x squared, we know it's this graph, isn't it?
Yes.
Then we can obtain the entire graph by simply reflecting about the x-axis because we know that it's symmetric. It's an even function, so it's symmetric about the y-axis, meaning that if we reflect this graph this side, then we get the full graph. That's what they are saying. Now they're saying that the other way around. If f satisfies this, meaning that if you put, look at this, f of x is equals to x to the power of 3. If I put negative inside here, do you agree that the negative still, if we put this becomes negative x to the power of 3. So meaning that this becomes negative of the function f of x. So then we say that function is odd. Are we all together there?
Yes, ma'am.
Yes, ma'am.
Uncle.
Yes, ma'am.
So here they're just describing the even and the odd function. Do you see that? Okay, there's something I didn't mention. Okay, I think they'll mention it somewhere. Let f be a function. So if an even function is that if you put an x, you get the original f of x for all values of x in the domain, then you say the function is even. If f is odd, then you put an x and you get negative of the mother function. Then we are saying that the f is odd. Now they say the graph of an even function, meaning that all even functions, their graph are symmetric about the origin, meaning that half of that graph, if you go up, not about the origin, about the y-axis. So if you go and cut the y-axis, this half here will look exactly the same as that half there. I will all together. Now they say the graph of an odd function is symmetric with respect to the origin, meaning here. So meaning that this half here, when you reflect it about this origin, it will be the same as this half here. Are we together?
Yes, ma'am.
Now they say determine whether the functions are even or odd, or neither even or odd. By looking at the first function, do you think it will be even or odd?
Odd.
Odd, ma'am.
Let's try it.
It's
So
odd.
meaning that, let's go A, meaning that f of minus x is equals to minus x to the power 5 plus minus x, isn't it? So this is equals to minus x to the power 5 minus x. What do I do here? Do I leave it like this? Yeah?
No.
What do I do? What do I do?
The common fact.
Yeah, common factor, ma'am.
Thank you. So you take
Negative
out the
one.
-1 outside, then you're left with x
Common fact.
to the power of 5 minus
Right.
x. So then you can see this is plus, ne? So we can see this is f of x. So this is minus f of x. And we know according to the rule, if this is equals to that, then we say that is a odd function. Next one, even or odd?
Even.
Even.
Even, ma'am.
Let's see. So we have b, g of negative x is equals to 1 minus x to the power 4. So this is equal to minus x to the power 4, which is g of x. Well done. Even c.
Neither.
Why are you saying neither? Are you saying neither because the other one was odd, the other one was even, and you think this one will be neither?
No, ma'am.
Okay, let's see. Because we have h of minus x is equals to 2x minus x. Sorry, my bad. So this is 2 minus x minus x squared. We know this will be 2 minus 2x minus x squared. Even if we take out the negative, we still have 2x plus x squared. So we see there's a new function now, which I don't know which it is. So this is not equals to h of x. So this means it's neither even nor odd. Are we okay there?
Yes.
All right.
Yes, ma'am.
All right. So let's see. Let me discharge. Discharge. We are right. 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 You see, when we are right, we're just skipping pages. Look at that. Okay. Now, the graphs of the function in example A are shown. Which are these ones? Do you see that the first one is even? And what did we say about the reflection of even?
You said it's
We
Ma'am,
said,
can you repeat
no,
the question?
the first graph, we said it's odd, ne? We said the first graph is odd, ne? And we said the graph of an odd function, it's symmetric way. But it's written. Okay, I'm asking a question that is written, sorry. The graph of f is symmetric about the origin, and the graph of g is symmetric about the y-axis. The graph of h is not symmetric about either of the y-axis and the origin. I'm asking a question that is written here. My apologies. Do you see that, guys? So
yes,
all
ma'am.
graphs, all odd graphs, they are symmetric about the origin. All even graphs, they are symmetric about the y-axis. And the ones that are not even or odd, they're not symmetric about the origin or the y-axis. They might be symmetric about, I don't know what line, y. Like this one, if this is 2, for example, if this is 2, this is x equals to 2, then it means that this graph is symmetric about x equals to 2 because this half is the same as that half. Done.
Yay.
Any question? I'm also saying
No.
yay. Okay, then I'm stopping the recording.
Are we done?
Yes, you want more?
No,
No, just
rest.
curious.